This lecture shows how to predict an event given a network and its parameters. This presentation was prepared by Dr. Alemi. The effect of changes in a network can be calculated by repeatedly going through two steps known as joining and eliminating. Let us start with a simple tree with three variables shown on the right-hand corner: patient severity, patient's preferences for DNR, and treatment choices. Our task is to estimate the probability of treatment. To start with, we have two tables, one providing the prior probability of severity and the other conditional probability of DNR order at different levels of severity. We will try to first join these two tables. The joining works like joining of tables in SQL. The tables are joined on variables they share, in this case severity of illness. The values of the new joint table are provided by multiplying each conditional probability by the prior probability of the condition. For example, the first row of the new joint table is provided by multiplying the probability of being severe, 0.1, from the first table to the conditional probability of DNR for severe patients, 0.8, from the second table. The resulting new table can be used to join with another, but before we join to another table, we need to eliminate the variables that we are not interested in. Elimination is done by summing over the variables that we are not interested in. Since we want to estimate the probability of treatment, we are not interested in the patient's severity. We can eliminate this variable by summing across it. To show the summation easier, we should sort it over the variable we want to keep. Then we sum the values for DNR and no DNR. This new table no longer indicates severity of illness, but reflects the influence of severity. For our next step, we join our new table with the conditional probability of treatment given the DNR. We are joining the two tables on the shared variables across the two tables. In this case, the two tables share the DNR choice. As before, the shared feature across the two tables is used to multiply the related probabilities. Since we are interested in the probability of treatment, then we can eliminate the DNR variable by summing across it. Since these calculated estimates do not always add up to 1, we normalize the estimates so that they do. So in the final estimate, we have that 81% of patients received the treatment. We have been able to go through the tree and estimate the probability of treatment. If a variable is substantiated, meaning that it has occurred, then we remove all rows corresponding to the unsubstantiated levels of the variable. Then we first join all substantiated variables. Then join a table with a variable not needed at the end of the calculation. This is done through multiplication of probabilities of joined tables. Next, eliminate the unneeded variable. This is done through summation. If all unneeded variables are eliminated, then normalize and use the estimated probabilities. Let us look at an example. Let us assume that we want to predict the outcome of severe patients. Therefore, rows that correspond to not severely ill patients should be removed from all tables. These are the 4 local tables in our network. Since we are focused on severe patients, the rows from 3 tables about not severely ill patients are removed. Typically, this is done by a where SQL command at the point of joining tables. This code says that we should join the two tables. Since they have no shared features, the join is cross-join. After the join, the probability of combination of events are calculated as a product of the probabilities. It also says that the join should be limited to severe cases. The resulting join is shown here. The probability of severe illness and DNR is estimated as 0.16, which is the product of 0.4 in the other two tables. We cannot eliminate neither DNR or severity from this table, as these variables are also used in remaining network structure. Severity is used in both treatment and outcome tables, and DNR is used in the treatment variable. In the next step, we want to join the combined table of severity and DNR with the table of treatment. The SQL for this join is given as shown. Note that the two tables now share two features, severity and DNR orders. The resulting table is provided here. Note that only severe cases are carried through the join, as the earlier tables do not have cases of not severely ill patients. Note that the probability in the resulting tables do not add up to 1. This is okay. These estimates do not have to add up to 1. We can now remove the DNR variable, as it is no longer in use in any remaining table. We can eliminate DNR by grouping by the other variables in the table and summing across DNR. The code and the result are shown here. In our final join, we would join with the table on outcomes. The two tables that we need to join are shown here. Note how the non-severe cases are no longer part of each table. Note again that in the new table of treatment, severity and outcome, the calculated probabilities do not add up to 1. These numbers are proportional to probability, and normalizing them to add up to 1 results in the calculated probabilities. Next, we try to eliminate all variables that are not needed and calculate the probability of positive outcome. Here again, we sum across the groups we want to and leave the variables that we are not interested out of the group by statement. A network model may seem complex, but cycles of joins and elimination will allow us to predict the probability of any event within the network.